Welcome. Today we'll sketch the polar curve or squared equals sine of 2 theta and find the area enclosed by one loop of this curve. Let's start by drawing our polar coordinate system. Here we have our polar grid, with concentric circles representing different values of r, and rays from the origin representing different values of theta. For our curve, our squared equals sine of 2 theta, we need to understand that it will be positive when sine of 2 theta is positive, and it will be 0 when sine of 2 theta is 0. Since sine of 2 theta has a period of pi, our curve will have multiple loops. Let's trace out one loop of our curve. Notice how the curve starts at the origin, when theta equals 0, expands outward as sine of 2 theta becomes positive, and then returns to the origin when sine of 2 theta becomes 0 again. To find the area enclosed by one loop, we'll use the formula for area in polar coordinates. The area equals 1/2 times the integral from alpha to beta of r squared with respect to theta. For our curve, we'll integrate from 0 to pi over 2 and substitute our squared equals sine of 2 theta. This gives us 1/2 times the integral from 0 to pi over 2 of sine of 2 theta with respect to theta. Let's solve this integral. Using the substitution u equals 2 theta, we get negative 1/2 times cosine of u over 2, evaluated from 0 to pi. This gives us 1/2, which means the area of one loop is 1/2 square units. And there we have it. We've sketched the polar curve or squared equals sine of 2 theta and found that the area enclosed by one loop is 1/2 square units. Thank you for watching. Remember that when finding areas of polar curves, we use 1/2 times the integral of r squared with respect to theta.